NASA recently dropped a bombshell. An invisible monster is on the loose in space, a runaway black hole with a staggering mass of about 20 million suns. Black holes are among the most fascinating and mysterious phenomena in the universe, with the ability to warp space-time and an insatiable appetite for anything that dares to come too close. But for years, these cosmic giants were purely theoretical, and scientists struggled to gather tangible evidence about them. Until now. A recent breakthrough has given us the sharpest image of a black hole ever captured, and it's more than just a pretty picture. This image could revolutionize our understanding of black holes forever. But before we dive into the significance of this groundbreaking photo, let's take a step back and explore how black holes went from theoretical curiosity to an actual scientific discovery. The story of black holes begins long before scientists had the technology to actually observe them. The idea of these unseen cosmic giants dates back to 1783, when an English natural philosopher named John Michell first proposed the possibility of dark stars, objects so massive and dense that their gravity was so strong, not even light could escape. Michell's theory planted the seed for what would become one of the most profound discoveries in modern astronomy. Fast forward to 1916, and the brilliant Albert Einstein published his theory of general relativity, which fundamentally altered how we understand gravity and the fabric of spacetime. According to Einstein, massive objects can warp the space around them, bending and twisting it. This concept, once challenging the earlier Newtonian model of gravity, hinted at the possibility that some objects could distort spacetime so severely that they could trap everything, including light, black holes. For a long time, however, black holes were treated as a purely theoretical concept. The idea of something so extreme, where the laws of physics seemed to break down, was dismissed by many. Even though Einstein's theory suggested their existence, most scientists didn't take the notion seriously, thinking it was too bizarre to be true. But then, in the 1970s, something extraordinary happened. Astronomers Paul M. Tan, Thomas Bolton, and Lise Webster made a groundbreaking observation. They detected a strange, invisible object orbiting a blue supergiant star about 6,000 light-years away in the constellation Cygnus. This mysterious object, later named Cygnus X1, was emitting intense X-rays, high-energy radiation that typically only comes from extreme cosmic events, like supernovae or objects with enormous gravity, like black holes. The fact that it was invisible to optical telescopes raised a huge red flag. It was clear that this was something extraordinary, and as they investigated, scientists realized they were staring at the first confirmed black hole in space. But how do scientists study something that's invisible? While black holes themselves can't be seen, their gravitational pull has a profound impact on nearby objects. For instance, a star orbiting a black hole will show a Doppler shift in its light as it accelerates due to the black hole's gravity. By measuring this shift, astronomers can calculate the black hole's mass. Additionally, black holes often act like massive cosmic lenses, bending and distorting the light from objects behind them, a phenomenon known as gravitational lensing. Black holes are truly everywhere. In fact, it's now believed that supermassive black holes sit at the centers of most galaxies, including our very own Milky Way. Some estimates suggest that there may be as many as 400 million black holes in the Milky Way alone. The scary part. We simply hadn't noticed them for most of human history. These cosmic bullies are always lurking in the shadows, swallowing anything that gets too close, stars, gas, even entire planets, without ever letting anything escape. But black holes aren't just about devouring everything in sight. They are also some of the most fascinating and perplexing objects in the universe. Despite their fearsome reputation, black holes hold clues to some of the biggest mysteries in physics. And, as it turns out, the deeper we dive into studying them, the more bizarre and mind-bending theories begin to emerge. One of the most tantalizing questions is what happens inside a black hole. The answer is still shrouded in mystery. A black hole is divided into three regions: the event horizon, the singularity, and the outer layers. The event horizon marks the point of no return. Once anything crosses this boundary, it's inevitably drawn towards the black hole's center, where space-time is warped beyond recognition. Inside, all the normal rules of physics break down, and everything, matter, light, and energy, gets compressed into an infinitesimally tiny point at the singularity. But here's the real kicker: scientists have begun to propose some truly mind-blowing ideas about black holes. One such theory suggests that black holes might not be the end of the road, but rather a gateway, a portal to another universe or even another dimension. Picture this: if we could somehow develop technology that allows us to travel faster than light, something that's currently considered impossible, we might one day step into a black hole and emerge somewhere completely different, perhaps in a distant galaxy or even an entirely different universe. It's the kind of idea that sounds straight out of a science fiction movie, but it's actually based on real scientific principles. And then there's the holographic hypothesis, proposed by scientists like Enrico Raldi. According to Raldi's holographic duality theory, black holes might not be what we think they are at all. Instead of being solid objects with a mysterious core, Raldi suggests that black holes could be holograms, projections of information from a two-dimensional surface that we perceive as three-dimensional. This idea is grounded in the holographic principle, a theory that suggests all the information about a region of space can be encoded on the surface of that space, like a hologram. This theory doesn't just challenge our understanding of black holes, it could change the way we view the entire universe. If we are indeed living in a holographic projection, then everything we know about reality might just be a shadow of something far grander. Imagine that, entire universes, each with their own laws of physics, all potentially existing as projections on some cosmic surface. It's an incredibly mind-bending thought, and while it's still a theory, it's one that could redefine everything we know about space, time, and existence. So, how do we study these cosmic mysteries? Thanks to the incredible work of the Event Horizon Telescope, EHT, team, we now have concrete evidence of what a black hole looks like. The first image of the black hole at the center of our galaxy, Sagittarius A, was captured recently, and it's nothing short of spectacular. While the black hole itself is invisible, as it absorbs all light, we can see its unmistakable signature in the form of a bright, fiery ring of light surrounding a dark core. This glowing ring is created by the intense gravity of the black hole bending light as it spirals toward the event horizon. This black hole, located around 27,000 light-years away, is 4 million times more massive than our Sun. And while it may seem far away, capturing this image was no easy feat. The EHT team had to create a virtual telescope the size of the entire Earth by connecting 8 radio observatories around the world. They observed Sagittarius A for several nights, capturing hours of data in what was essentially an extended exposure. The result? A stunning image that not only confirms the existence of Sagittarius A but also offers fresh insights into how black holes interact with their surroundings. But the excitement doesn't stop there. The EHT team had already captured an image of another black hole before Sagittarius A, the one at the center of the galaxy M87, located in the Virgo constellation. This black hole is 6.2 billion times the mass of our Sun and is surrounded by a brilliant jet of gas and radiation that extends across the galaxy. The image of M87's black hole was the first direct photograph of a black hole's shadow, and it's providing scientists with invaluable data about the nature of black holes and the way they influence their surroundings. M87's black hole is particularly fascinating because it's actively spinning, and emitting a powerful jet of radiation. This jet is a result of gas being sucked into the black hole and accelerated to nearly the speed of light, creating an incredibly bright beam that stretches for light years. Studying this jet allows scientists to learn more about how black holes can shape galaxies and even regulate star formation by heating and expelling gas. Now, with both Sagittarius A and M87 providing detailed images and data, scientists have the opportunity to compare two very different black holes. This is an unprecedented opportunity to test Einstein's theory of general relativity in extreme conditions and deepen our understanding of the fundamental workings of the universe. The mysteries of black holes are far from solved, but each new discovery, each new image, brings us one step closer to understanding these cosmic monsters. Who knows what we'll learn next? Maybe one day, the knowledge we gain from black holes will unlock the secrets of the universe, or even allow us to travel to distant galaxies beyond our wildest imagination. If this video has piqued your interest, don't forget to like, comment, and subscribe for more mind-blowing insights into the universe. And remember, the more we learn about the cosmos, the more we realize how much